Welcome to A-Level Mathematics. In this lesson, you'll learn binomial expansion step by step, from simple expansions to solving examination-style questions.
By the end of this lesson, you'll understand binomials, expand expressions, use Pascal's triangle, apply the binomial theorem, and solve problems involving coefficients and specific terms. A binomial is an algebraic expression containing exactly two terms. Examples include x plus 2, 3a minus 5, and 2x, x plus y. Binomial expansion simply means multiplying the same binomial several times. Fortunately, mathematics provides faster methods than repeated multiplication. Let's begin with a simple example. Expand x plus 2 all squared by multiplying each term inside the first bracket by every term inside the second. After multiplying every term, combine like terms to obtain x squared plus 4x plus 4. Using exactly the same process, x plus 3 all squared expands to x squared plus 6x plus 9. When the second term is negative, the middle term becomes negative, because negative 5x appears twice. For powers of 3, repeated multiplication becomes longer, so mathematicians often use coefficient patterns instead. The expansion becomes x cubed plus 6x squared plus 12x plus 8. These coefficients come from Pascal's triangle, one of the most useful tools in binomial expansion. Each row corresponds to a power. For example, power 4 uses the coefficients 1, 4, 6, 4, and 1. Let's use Pascal's triangle to expand x plus 1 raised to the fourth power. Multiply each coefficient by the appropriate powers of x and 1. The completed expansion is x to the fourth plus 4x cubed plus 6x squared plus 4x plus 1. For larger powers, mathematicians use the binomial theorem instead of Pascal's triangle. The binomial theorem generates every term of an expansion using a single mathematical formula. The expression n choose r is called the binomial coefficient, and it determines each numerical coefficient. Let's apply the theorem by expanding x plus 2 raised to the fourth power. Calculate every term carefully, remembering to raise both x and 2 to their required powers. The completed expansion is x to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. When the second term is negative, the signs alternate depending on whether the power is odd or even. Notice that only the odd-powered terms become negative, while the even-powered terms remain positive. Sometimes examination questions ask for only one particular term instead of the four. Since the fourth term corresponds to r equals 3, substitute that value into the general term formula. After simplifying, the fourth term is 4,320 x cubed. You may also be asked to find the coefficient of a particular power of x. From the completed expansion, the coefficient of x squared is simply 80.
Avoid common mistakes. Use the correct Pascal row. Raise both terms correctly, and remember that negative numbers raised to odd powers stay negative.
Remember, a binomial has two terms, Pascal's triangle gives coefficients, the binomial theorem handles larger powers, and the exponents move in opposite directions.
Pause the video and try these practice questions on your own before checking your answers.
Great job completing this lesson on binomial expansion. Keep practicing to build speed and accuracy for your A-level examination.